Hello, good evening, student. Today we are starting discussions of some important chapters of the mathematics. The differentiation. Differentiation, it is the branch of calculus which is deals with the study of differentiations of the algebraic function, trigonometric function, logarithmic function, and some exponential function. What is meant by the differentiation? In these lectures, we have started discussion some introductions of the differentiations, and we give the importance of the differentiation. Why we are studying the important and interesting chapter, that is the differentiation, because on which chapters the whole calculus or the mathematics part 2, sorry, that is the mathematics part 1 is defined, that is 12th standard mathematics chapter number 1, differentiations. These chapters, the whole mathematics will be depends, or the whole calculus will be depends. The differentiation and integrations are the main important, interesting, and more marks getting chapters in the mathematics part 1 of the 12th standard Maharashtra state boards. The differentiation and integrations both are the interrelated to each other, or the inverse functions of the each other. What is meant by the differentiation? The differentiation of the any function is the functions will be vary in that terms or in that parameters, if the parameters get changes. We know that in the physics the velocity is the differential function. Velocity or velocity is the derivative of displacement. Why? Because velocity is formed if the displacement gets changes over the time. Displacement is changes over the time, the velocity will be formed. The velocity or linear velocity, that is ds by dt. The displacement, it is a function of the displacement of the particles changes over the time dt or with respect to time t. That's why the velocity is the time derivative of displacement. Velocity is time derivative of displacement. What if the differential? What if the displacement of the particles could not be changes over the long and long times? That means that velocity of the particles will be zero. Differentiations of these particles or the time differentiations of the displacement of that particles will be zero. That means velocity is zero. Now we discuss some important formulas about the differentiations who need to solve the differentiate or derivative of the some different function, that is algebraic functions, trigonometric functions, exponential functions, logarithmic functions, and some others. And how would you calculate the derivatives of the functions and solve some easiest example? This is the introduction lecture. Try to take the heading, that is introduction. Please make the chart for writing the formulas, and it is must be written on the first page of the chapters or the notes of that chapter, that is derivatives. Now, that is here the function, there are different types of the functions and their derivatives. There are some important formulas, functions and the derivatives. The function, that means f of x, which is equal to the functions y, the functions in the form of x. Y, it is the functions in the form of x, and the derivatives of that functions, time derivative, that is differentiated with respect to x, that is dy by dx, or also denote like f dash of x. In the left hand side, we written the functions, and what are the derivatives of that function will be written in the right hand side. This is f dash of x or dy by dx. Then first, what is the derivative of constant c? What if the displacement could not be changes over time t1 to t2? Displacement is the same, that is s1, and s1 is also at a time t2. Displacement could not be changes. That means displacement is a constant. Particle does not move. Particles are not under the motion. Particles are at rest over a long and long time, and the velocities of that particles over the time is zero. That means we calculate the time derivatives or derivative with respect to some parameters of the another functions is zero when these functions could not be changes or could not be varies. That means it is a constant. The derivatives of constant will be zero. What if the functions having some power? That means f of x, which is equal to x raised to n. F of x, which is equal to x raised to n. The derivatives of that function will be n into x raised to n minus 1. derivatives of that functions. N is the any integer, any positive integer, negative integer, any numbers, any constant numbers, and x is a maybe single parameters, or x is in the form of functions. It is a separate functions having some power, some indices or some integer indices, then we use these formulas or rules, that is n into x raised to n minus 1. If x raised to 5, what is the derivatives of that function? That is dy by dx, which is equal to n equal to 5. We're taking product, that is 5 into x raised to 5 minus 1, which is equal to 5x raised to 4, which is the derivative of x raised to 5 with the help of using this formula. What is the derivative of root x? We just starting discuss the differentiations of the algebraic function, then differentiation of trigonometric function, differentiation of logarithmic function, differentiation of exponential function, then solve some simple formulas, simple questions, simple problems like that, and then go to the next step. What is the derivatives of root of x? It will be 1 upon 2 root of x. How it comes like that? Consider what is the derivative root of x. What is the actual value of root x, which is equal to x raised to 1 by 2. Apply the same formula, that is x raised to n, which is equal to n means 1 by 2 into x raised to n minus 1. That means 1 by 2, which is equal to x raised to minus 1 by 2. Minus means it gets denominator 1 upon 2 into x raised to 1 by 2. What is the value of x raised to 1 by 2? Will be 0. Sorry, x raised to 1 by 2, which is under root of x. That means the derivative of root of x, which is equal to 1 upon 2 root x. What is the derivative of 1 upon x? The derivative of 1 upon x, which is the same, that is, if the any functions at the denominator, that means the indices of the similar functions or the indices of x at the numerator, which is equal to minus 1, using the formula minus x raised to minus 1 minus of 1. That means minus minus, that is plus, minus x raised to minus 2, when it is comes to denominator, this negative sign is changed into the positive minus 1 upon x square, which is minus 1 by x square. Here some derivatives or differentiations of the algebraic functions. These are single terms. What if the x is not a single term? X is a function independent functions. For example, that is a cos of then 2x square plus 5x. This is the functions. It is not a single parameter or single term x. Here there are many different parameters or the functions inside the functions, or again that is x raised to 2x. How we can calculate it? Here one single functions and their indices or the indices of the functions is another one functions. Or what if that is 2 of 2 into 2x square plus 5x, here with another functions, or the function that is cos of 2x plus 5. Here are some different functions. First of all, calculate the function derivatives of cos x, and then first time 2x plus 5 treated as a single parameter as x, then function of a cos x or derivative, calculate derivative of cos x, which will be anyone. Then again differentiate the separate function, that is 2x plus 5, like that. Dy by dx, which is equal to, first of all, calculate the functions of the cos of 2x plus 5 treated 2x plus 5 is a single parameter. Then again calculate d by dx of separate this function, that is 2x plus 5. It is a rule for calculating the differentiations. Now we taken the example of cos x just to find what is the derivative. Write the derivatives of cos x. Or first, what is the derivative of sin x, which is cos of x. Derivative of sin x is cos x. That means derivative of cos x is the negative of sin x. Derivative of cos x, which is equal to minus of sin x. Here some trigonometry functions. What is the derivative of tan x? Tan x, which is equal to sec x derivative of tan x which is equal to sec square x, and derivative of sec x which is equal to sec x into tan x. Here the students are getting confusions. If the derivative of tan x which is equal to sec square x and derivative of sec x is not equal to tan square x, the derivative of sec x which is equal to sec x into tan x. Just try to solve all the formulas with the help of derivative of sin x which is equal to cos x and derivative of cos x which is equal to sin x. Then the next one is, what is the derivative of cot x? The next trigonometric function is cot x. What is the differentiation of the function, that is cot of x? If the function is cot x, the differentiation of cot x is minus cosec square x, and if the derivative of cosec x which is minus of cot x into cosec x. Here some derivatives of trigonometric and as well as algebraic function. Now, derivative of logarithmic functions, it is only single formula, derivative of log x which is equal to 1 upon x. Very simple. Derivative of log x is 1 upon x. It may be at the place of x, it is comes as a separate function, or the function is hidden at a place of x. Then first of all calculate the functions. This whole function treated as a single parameter, that is x. First of all calculated the log of x, then again derivatives of the x. Then what is the differentiation of exponential function? It could not be changes. E raised to x which is equal to e raised to x. The derivatives of exponential function could not be changes as similar. And what is the derivative of a raised to x which is equal to a raised to x into log of a. Here some important formula. It may be 10 to 12 formulas. Yes, 12 formulas, that is 3. These are the 4 and 4 plus 6. It may be 11 formulas here, which is most important formulas, and try to solve some numericals, some function, try to derivatives or differentiation of some function with the help of these all formulas. First of all, what is the y? The functions y which is equal to 2x square, 2x cube plus 3x raised to 5. Differentiate this function with respect to x. Differentiate with respect to x. What if in the function there comes 2 or more parameters or 2 or more terms? How the different derivatives, how to calculate the differentiation of that functions, how you take the derivatives of that functions? It must be simple. dy by dx which is equal to d by dx of, use the separate derivative of each and every terms if they are separated by addition and subtraction. If they are separated, multiplication, division, they have some different rule. Will be discussed in the next lecture. This is the first lecture, which is introductions of the differentiation. Then dy by dx, differentiations of this function with respect to x, which is equal to d by dx of the first term 2x cube plus the differentiations of the second functions, that is 3x raised to 5. 2 is a common which is multiplied with the function, which is 2 is a constant which is multiplied with the another one functions, which may be taken the common, or it must be taken the common, that is dy by dx which is equal to 2 into d by dx of x cube and 3 into d by dx of x raised to 5. We have some ideas which formulas apply here, because x raised to n, x raised to 3, that means x raised to n formula will be applicable here. Then the differentiation of this function, that is dy by dx which is equal to 2 into, that is 3 is the n, 3 into x raised to 3 minus 1 plus the similar formula is applied here, that is 3 into, what is the value of n, that is 5, x raised to n which is equal to n into x raised to n minus 1. Here the 5 into x 5, that is x raised to 5 minus 1. Now dy by dx which is equal to 2 into 3, that is 6x square, x raised to 3 minus 1 is x square plus, that is 3 into 5, 15 x raised to 4. Here we taken 3x square common, dy by dx, which is equal to 3x square into 2 plus 5x square. This is the derivative of the function, that is 2x cube plus 5x raised to 3x raised to 5. Then what is the derivative of if the y equal to under root of sine x? How we calculated these one derivatives? Because it is not a simple problem, because in these problems, first of all apply this formula for the root, and again inside the root we have some trigonometric function. How it can calculate? First, apply the square root of x. What is the differentiation? This sin x treated as a single parameter, that is x, and differentiation this function with respect to x. Differentiate these functions with respect to x. Now, dy by dx, which is equal to d by dx of root of sin x. After the calculating the root of sin x, again differentiation the function of sin x. Then now here dy by dx, what is the differentiation of root x? Root x, which is equal to 1 upon 2 root x. Now 1 upon 2 into root of sin x into separate differentiations of sin x. Now we know that what is the differentiation of sin x is a cos x. That means the d by dx of the sin x is cos x. Cos x upon 2 root sin x. It is the final answer of the derivatives of the functions which are y equal to under root sin x. Here we again solve on another problems and stop here. Now, what is the derivatives of, what is the differentiation of log of sine of x square plus 5, which is the last one, and it may be some difficult problems here. In these problems, we apply the all formulas, all important formulas here. First of all, the logarithmic functions, it is the main function. Inside the logarithmic functions, some trigonometric function is hidden. Inside that trigonometric function, some algebraic function will be hidden. That means, first of all, try to solve try to derivatives or differentiation of these functions from outside to inside the function, that is y equal to log of sin x sine of x square plus 5. Now first differentiate these functions with respect to x. These functions are in the form of, that is f of g of x. F of g of x. First of all calculate the, that is f dash of g of x and d by dx of g of x, which is the pattern to solving the derivatives of the problems like that. Now first of all differentiate with respect to x dy by dx, which is equal to, first of all, d by dx of the functions log of sine of x square plus 5. What is the derivative of log x is 1 upon x. Now sine of x square plus 5 treated as a single parameter, that is x only. What is the derivative of log x, which is 1 upon x? What is the x here? Sine of x square plus 5. Now dy by dx, the differentiation of the function with respect to x, which is equal to 1 upon, what is the x? That is sine of x square plus 5. Must be remember it again, differentiation of this x, that is sine of x square plus 5. Now the next step, dy by dx, which is equal to 1 upon sine of x square plus 5 as it is. What is the derivative of, now x square plus 5 treated as a single parameter, that is x. Now sin x, which is a cos x, derivative of sin x is a cos x, that is cos of, what is the x? X square plus 5. Again differentiate these x as a x square plus 5. The both parameter terms are combined to each other, because which is separated by multiplication symbol. We combine, that is cos of x square plus 5 which is divided by sine of x square plus 5 into differentiate. These functions are separated. These functions with having the two terms are separated by positive sign. That means we give the separated, that is d by dx of x square plus d by dx of 5. Now we know that what is the we treated x square plus 5 as a single parameter, that is cos upon sin is cot. Cos upon sin is cot. It is a trigonometric function. Cos upon sin is cot. What is the x? That is x square plus 5. Now dy by dx, which is equal to cot of x square plus 5. What is the derivatives of x square? Which is we apply x raised to n formula, that is 2x into 2x. What is the derivative of 5 will be 0, because the derivative of constant is 0. The constant values could not be varied with respect to any parameter. It may be x. Cot of x square plus 5. Here it is the differentiations of the functions in this formula. In these problems, we try to use logarithmic functions, formula for logarithmic functions, trigonometric functions, algebraic functions, and indices of that. And last one problem calculated some exponential functions here. What is the derivatives of if the y equal to e raised to cot x? Here again there are two formulas, two different functions are combined to each other. First one, exponential function. Inside the exponential function, one trigonometric function will be hidden. Then first of all, calculate the derivatives of main function, that is the exponential function, and then we can calculate the differentiations of the hidden functions. That is, differentiate y with respect to x. Now dy by dx, which is equal to d by dx e raised to cot of x. We know that exponential function, derivatives of the exponential function could not be changes. Yes. Now dy by dx, which is equal to e raised to cot of x into differentiation, separate differentiation of cot x. What is the differentiation of cot x? Will be written formula like here. That is dy by dx, which is equal to e raised to cot x into minus cos x square x. Now minus sign taken common, that is dy by dx, which is equal to minus e raised to cot x into cos x square x. Here the derivatives of the functions, that is e raised to cot x. Now we are stop here. In the next lectures, we are trying to solve the exercise 1.1 from the 12th standard mathematics of the Maharashtra State Board. Okay.